Good morning children. Today we are going to learn the concept properties of the number systems under the topic number system. Children, till now we discussed about what are the natural numbers, what are the whole numbers, what are the integers and what are the rational numbers. Now we are going to discuss some properties of these number systems. In that first one is closure property, second one commutative property, third associative property, fourth existence of identity, distributive laws. Like that we have some properties of these number systems. Let me discuss one by one clearly. In that first one is closure property. What is meant by closure property? Let us see here. Children, I consider two natural numbers. Children, here I consider two natural numbers in the set of natural numbers. So now I want to add those two natural numbers. So 1 plus 2 is equal to how much? 3. 3 is also a natural number or not? Yes, 3 is also a natural number. Now I want to subtract 2 from 1. Now I want to subtract 2 from 1. So that means 2 from 1 is nothing but 1 minus 2 gives how much? Minus 1. Is minus 1 is a natural number? No, minus 1 is not a natural number, right? Now I want to multiply those two natural numbers. 1 into 2 gives what? 2. 2 is also a natural number, right? Now I want to take division of these two natural numbers. Like 1 is divided by 2 gives what? 1 by 2. Is 1 by 2 is a natural number? No, 1 by 2 is not a natural number. If we observe clearly here, if we consider two natural numbers instead of natural numbers, then addition of the two natural numbers is also a natural number. Addition of the two natural numbers is also a natural number. Multiplication of the two natural numbers is also a natural number. That means we can say that this set n, this natural number set n, is closed under addition under the operation multiplication also. N is closed under addition and also n is closed under multiplication. This property is called closure property. This property is called closure property. So here n is not closed under subtraction. Natural numbers is not closed under subtraction. Similarly, natural numbers is not closed under division also, because here we consider two natural numbers, but subtraction of those natural numbers is not a natural number. Division of those natural numbers is also not a natural number. So that we can say n is not closed or n is does not exist. N is not closed under subtraction and division. Okay, this is called closure property. Let us see the definition of closure property clearly here. Let S be an non-empty set. Here S is nothing but either of these sets, either natural numbers, whole numbers, integers or rational numbers, or any other set, even numbers, odd numbers, prime numbers, composite numbers, like that. We can take any one, positive rational numbers, like that we can take any one. So here I have taken only these four number systems. S is any of these four number systems. Let S be a non-empty set, and for any a comma b belongs to S. That means if we take S is natural numbers, if we take S is natural numbers, then a comma b are natural numbers. If we take S is whole numbers, then a comma b are whole numbers. If we take S is rational numbers, then a comma b are rational numbers. If we take integers, then a comma b are integers, like that. If a binary operation b belongs to S, here binary operation is either addition or subtraction or multiplication or division. If we take addition here, the binary operation is addition and S is natural numbers. If a plus b belongs to n, if a plus b belongs to n, here I consider two natural numbers a and b, and if a plus b is belongs to natural numbers, then we say that this n, then we say that here we have taken S as natural numbers, this n is closed under the operation addition. Then we say that n is closed under the operation addition. This is called closure property. This is called closure property. So let S be a non-empty set, and for any a comma b belongs to S, if a binary operation belongs to S, then we say that S is closed under the operation this. This is called closure property. Let us see existence of closure property. That means in which number systems the closure property is exist. That means if natural numbers is closed under addition, then we say that closure property is exist for natural numbers under addition. Let us see clearly one more. So I consider two natural numbers 2, 3. Two natural numbers 2, 3. So 2 plus 3 is equal to how much? 5, right? 5 is also a natural number. So that closure property is exists for natural numbers under the operation addition. So here it is exist. For whole numbers, I consider two whole numbers 4 and 5 belongs to whole numbers. Sum of the two whole numbers gives 9. 9 is also a whole number, right? 9 is also a whole number. So that the closure property is exist for whole numbers under addition. In this also it is exist, right? For integers, I consider two integers -1 and 5. Now I want to add -1, 5 are the integers. Now I want to add those two integers. -1 plus 5 gives what? 4, right? 4 is also integer. 4 is also integer. So that closure property is exist for integers under addition. For rational numbers, I consider two rational numbers 3 by 2 and 5 by 2. 3 by 2 and 5 by 2 are two rational numbers, right? So now I want to add those two rational numbers. 5 by 2 plus 3 by 2 plus 5 by 2 gives what? Same denominator, right? Like this. 3 plus 5 is equal to 3 plus 5 by 2 gives 8 by 2. 8 by 2 nothing but what? 4. 4 is also a rational number or not? Every integer is also a rational number. So that if here I consider two rational numbers, then also we got a rational number. So that we can say closure property is exist for rational numbers under addition. Under addition, we can say simply here this all natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Natural numbers subset, whole numbers subset, integers subset, rational numbers. So if closure property is exist for natural numbers under addition, then it is also exist for remaining set of numbers. That means it is exist for whole numbers, integers, rational numbers, because every natural number is a whole number, every whole number is a rational number, every whole number is also a integer. So that if it is exist for natural numbers, then it is exist for remaining set of numbers also. Okay. Next, let us see in subtraction. Let us consider two natural numbers 1, 2. So now take 2 minus 1. 2 minus 1 gives how much? 1. 1 is also belongs to natural number. So if I take 1 minus 2 gives how much? Minus 1. Minus 1 is a natural number? No. Minus 1 is not a natural number. So that here 1 is a natural number, but for this operation it is does not exist. So that we can say natural numbers is not closed under the operation minus. Natural numbers is not closed under the operation minus. So that we can say closure property is does not exist for natural numbers under the operation subtraction. So here does not exist. For whole numbers, so here I consider 2, 3 belongs to whole numbers. Take 2 minus 3 gives what? Minus 1. Minus 1 is a whole number? No, minus 1 is not a whole number. So that here also it does not exist. Take two integers. Minus 1, some 4. I have taken two integers. Minus 1 and 4, two integers. Now take subtraction. Minus 1, minus 4. Minus 1, minus 4 gives what? Minus 5, right? Minus 5 is an integer? Yes, minus 5 is an integer. So that we can say closure property is exist for integers under subtraction. Closure property is exist for integers under subtraction. Exist. Okay. Now take rational numbers. Simply we can say it is exist for integers. Then also it is exist for rational numbers also, because every integer is also a rational number, right? See, some 2 by 3, 7 by 3 are two rational numbers. 2 by 3, 7 by 3 are two rational numbers. Now take 2 by 3 minus 7 by 3. 2 by 3 minus 7 by 3 gives what? 3 is the denominator. 2 minus 3 gives minus 5 by 3. Minus 5 by 3 is a rational number or not? Yes, minus 5 by 3 is a rational number. So that we can say closure property is exist for rational numbers under the operation subtraction. Okay. Now see multiplication. In natural numbers, let us take two natural numbers 2, 3 belongs to n. 2 into 3, 6. 6 belongs to, like that we can take any example. You can say simply product of two natural numbers is always a natural number, so that natural numbers is closed under multiplication. We can say simply like that also. Otherwise, take a example like this. 2, 3 are natural numbers. 2 into 3 gives what? 6. 6 is also a natural number, right? So that natural numbers is closure properties exist for natural numbers under multiplication. If it exists for natural numbers, then it is also exist for remaining all numbers. No need to check. So it is exist. It is exist. Otherwise, we have to verify. For take integers, -1, -3 are two integers. So product of the two integers, -1 into -3 gives what? Minus into minus plus, 1 into 3, 3. 3 is also an integer or not? So it is exist. So closure properties exist for integers under the operation multiplication. Similarly for rational numbers also. So if we see, that means if closure property is exist for natural numbers under addition, then it is exist for all numbers, all number systems. If suppose closure property does not exist for under subtraction, closure property does not exist for natural numbers under subtraction, then it is may or may not be exist for remaining set of numbers. Then it is may or may not be exist for set of numbers. If it is exist, then it is exist for remaining all set of numbers. If it does not exist, then it may or may not be exist for remaining set of numbers. Okay. So in division, let us see. 2, 4 belongs to natural numbers. 2, 4 belongs to natural numbers. Take division 4 by 2. 4 by 2 is nothing but 2. 2 is also natural number, no? So if 2 is a natural number, by writing exist, it is not correct. Take reverse also. 2 by 4. Reciprocal. 2 by 4. 2 by 4 means 2 ones, 2 twos. 1 by 2. Is 1 by 2 is a natural number? No. 1 by 2 is not a natural number. So that closure property does not exist for natural numbers under division. Does not exist. Does not exist. For whole numbers, same take this example only, because 2 and 4 also whole numbers, right? 2 and 4 also whole numbers. 4 by 2 gives 2. It is also a whole number. But 2 by 4 gives 1 by 2. It is a whole number? No, it is not a whole number. So that closure properties does not exist for whole numbers under division. Does not exist. Next for integers. Integers, -3, 5. -3, 5. That means -3 is divided by -3, 5 are the integers. -3 divided by 5 gives -3 by 5. Is -3 by 5 is an integer? No, it is not an integer. So that does not exist. Does not exist. Okay, take two rational numbers. Here I consider two rational numbers, 2 by 3 and 5 by 6. 2 by 3 and 5 by 6 are two rational numbers. Now I want to take division. 2 by 3 is divided by 5 by 6, which is nothing but 2 by 3 into, this can be written as into 5 by 6. You have to write the reciprocal, 6 by 5. So 3 ones, 3 twos. 2 twos, how much? 4, right? 2 twos, 4 by 5. 4 by 5 is a rational number or not? So here it is exist. For suppose, if we consider two rational numbers like 2, 0. 2, 0 are two rational numbers. Every integer is a rational number. If we take 2 by 0, 2 divided by 0. 2 divided by 0, which is what? Not defined, right? 2 by 0 is not defined. That means here it is exist. Closure property is exist for rational numbers under addition here, under division here. But here not defined is not a rational number, no? So here does not exist. So that we can give one conclusion is here that closure property is exist for rational numbers under division except 0. For except 0. Otherwise we can write closure property does not exist for rational numbers under division. Does not exist. So here the point is, if they ask a question like this, is closure property exist for rational numbers under division? The answer is does not exist. If suppose if they ask a question like this, is closure property exist for rational numbers under division except 0? Yes, it is exist. Okay. If they have given except 0 means yes it is exist. If they not mention except 0 means you can write does not exist. So this is the existence of closure property. In natural numbers, whole numbers, integers, addition. Closure property exists for these are all number systems under addition. Closure property does not exist for natural numbers, whole numbers under subtraction. Closure property exists for integers, rational numbers under subtraction also. Closure property exists for all these number systems under multiplication. Closure property does not exist for all these number systems under division. But closure property exists for rational numbers under division for except 0. Okay, I hope you understand. Thank you. This is about closure property. Okay, thank you.